Here we have a Dell Precision 7220 laptop that came in for repair. Customer mailed this over and it looks like he did not create a ticket. So we had to look up his name on the box and create a ticket for him. We already disassembled the board. And right off the bat, we noticed a short circuit on the board. How did we notice a short circuit on the board? We have the charging cable and you see a light on the charging cable. As soon as we plug the charging cable to the motherboard, look at what happens. We hear a sound and the light went off. A nasty sound and the light went off. So we know that we have a problem with the motherboard, a short circuit. I'm gonna disconnect the charging cable and reconnect to get it working again. We have a blue light again. So in order to get that blue light again, we have to disconnect the charger for a few seconds and plug it back in. Now what I want to do is remove this charging Flux, the charging cable from the board, and I want to plug the charging cable onto this connector, and the light is still on. The cable is good. We're going to plug that cable back on the board, and we have to figure this out. What's causing the short circuit? So that's where the cable plugs in. If we go to diode mode and we test and we do not have a short, 19 volts is being supplied by the charger through those 4 pins, 1, 2, 3, 4, and you can tell the layer is going here. Of course, the 2 power MOSFETs. Let's measure the gate on this one. We do not have a short. Measure the drain on this one. We have a large number. That's good. And if we measure the gate here, we have a large number, 1.1 voltage drop. And if we measure drain on this one, 0.6. So the readings are good. If we measure the current sense resistor in diode mode, we are reading a short. You see? I do not know where that short is coming from, but we are reading a short at the current sense. If we measure from gate to source, we have a high number. Gate to drain, we have a high number. That's good. So we're going to inject voltage at the current sense resistor, and we're going to monitor the board under a thermal camera and see what gets hot. We're going to turn on our NF dot short voltage injection tool. And we're going to inject, let's start at 1.5 volts. Turn the dial, turn the dial. If you do not know what this tool is, I have a video on it, a full video on this tool. You can purchase it directly off our site by logging into NorthridgeFix.com, click on shop, and you can buy all your tools from there. All items are in stock and orders almost always ship out same day. Oh, my HDMI mixer was slightly showing the other image. Let's inject voltage at the current sense resistor, and I do not see anything obvious. The board starts from right here. We're gonna ignore what's on the other side of my bench. The board starts from right here. Oh, I see something down on the bottom here. Watch. Watch the bottom right corner. See it? Right here. Something was getting hot right over here under this cover. Right now what we're gonna do is apply flux powder onto those two caps. We're gonna inject voltage and see where that flux powder evaporates first. We're gonna use an atomizer. If you do not already have one, you can purchase one off our site. And let's go ahead and do it. All right, so we applied flux powder using our atomizer. And now we're gonna inject voltage and see where that flux powder evaporates first. This one is better than alcohol because alcohol evaporates really quick, sometimes before you even inject voltage, whereas flux powder, it stays on the board until we inject voltage. And only the component that is shorting will melt that flux powder. All right, and I'm injecting voltage, and you can tell the cap on the bottom changed color. Now heat is very minimal on this area. We did see the heat spot on our thermal camera, but heat is very minimal. That's why we do not see a great change. But we can tell the component on the bottom discolored. If we inject voltage directly here, you see we have a shiny component here and we have a matte component here. The shiny components indicate that flux melted on this cap. It's not so obvious in this scenario, but I've done many videos where we use the atomizer and you can see a difference like day and night. So let's go ahead and desolder this component. You see, if we had a lot of heat, you would be able to tell how heat is spreading. And now that we are applying heat, flux powder melted. Let's see, do we still have a short? If we go back to our current sense resistor, right here, we're gonna measure. Do we still have a short? And look at this. We do not have a short anymore. We are reading 0.37. Wow, we got it. We got it. We got the bad guy. Say hello to the bad guy. Let's desolder this one as well. And we're gonna measure it. This one is likely 5 microfarads or 10 microfarads. One of the two. And we have a 10 microfarad, 9.93. That's a 10 microfarad capacitor. We have those caps on our site. You can buy them from there. We use 10 microfarads a lot, especially for Asus laptops. And right there. So I just grabbed the caps. I did not have them next to me. And this one is size 805. In case you're wondering, 805, 10 microfarads. Perfect. Those two caps are connected in parallel. So they bridge on the top and on the bottom. One more time, let's go here. Measure for a short. And we have 0.36, awesome. And we're done. I'm gonna hand this over to Big Boss to assemble and test, and I'll be back to finish the video. I'm just checking on Big Boss, and he said that this is one of the hardest to work on, this laptop, to reassemble it. A lot of bits and pieces, a lot of screws, and a lot of parts. So I'm gonna give him like maybe 15-20 minutes, and I'll be back. Let's check on Big Boss again. He called me. Oh, look at this. Nice. Laptop is working. and the reassembly was tough. But you're talking about big boss here, boss of all bosses. I hope you enjoyed the video. Let me know what you think. Leave it down in the comments. Don't forget to like and subscribe, and we'll do something else in the next video. Hey, what are you doing here?